Attaching conduits together back to back using mineralac straps is a violation of the National Electrical Code. This practice is not considered a secure method of attachment. According to the National Electrical Code, 2023 edition, Article 300.12b, wiring methods in materials states conductors and raceways shall not be laid haphazardly in walls, floors, or attic spaces. Article 358.30c concerns cable trays and states conductors shall be securely attached to the cable trays. Article 362.24b concerns cable bus and states conductors shall be securely attached to cable bus. The reason that back-to-back mineralac straps are a code violation is because they do not provide a secure attachment between the conduits. The conduits can move or vibrate when attached in this manner. This movement or vibration can damage the conductors inside the conduits. Damaged conductors can lead to electrical hazards such as short circuits, arcing, and even fires. Conductors and raceways must be securely attached to a solid surface to prevent movement and potential damage. Approved methods for securing conduits include firstly, cable trays, secondly, cable bus, thirdly, conduit straps, fourthly, conduit clamps, and fifthly, conduit hangers. These methods provide a secure and stable connection that will prevent movement and potential damage to the conductors inside the conduits. It is important to always follow the National Electrical Code when installing electrical systems. This will help to ensure the safety of people and property. The NEC provides specific guidelines for the proper installation and support of conduits. These guidelines are designed to prevent hazards and ensure the long-term reliability of the electrical system. Using back-to-back mineralac straps can create a situation where the conduits are not properly supported, leading to stress on the raceway system and potential failure over time. In addition to the general requirements for secure attachment, the NEC also addresses specific requirements for supporting conduits at certain intervals. These requirements vary depending on the size and type of conduit, as well as the location of the installation. Proper spacing and support are crucial for preventing sagging, bending, or other damage to the conduit system. When selecting a method for attaching conduits, consider the environmental conditions to which the installation will be exposed. In corrosive environments, it is important to use materials that are resistant to corrosion. This will help to prevent deterioration of the supports and ensure the long-term integrity of the electrical system. Furthermore, when installing conduits in areas subject to vibration, it is important to use supports that are designed to dampen vibration. This will help to prevent damage to the conductors and raceways. It is always best practice to consult with a qualified electrical inspector to ensure that your installation meets all applicable code requirements. An inspector can provide guidance on the proper methods for supporting conduits and can identify any potential hazards. Remember that electrical safety is paramount, and adhering to the NEC is essential for protecting people and property from electrical hazards. In summary, avoid using back-to-back mineralac straps to attach conduits, as this practice violates the NEC due to inadequate support and potential damage to conductors. Instead, use approved methods such as cable trays, cable bus, conduit straps, conduit clamps, and conduit hangers to ensure a secure and code-compliant installation. Always consult the NEC and local electrical codes for specific requirements related to conduit support and attachment. Proper installation and support of conduits are critical for maintaining the safety and reliability of electrical systems. Neglecting these requirements can lead to serious consequences, including electrical fires and injuries. Take the time to learn and understand the NEC requirements for conduit installation and always follow best practices to ensure a safe and code-compliant electrical system. Remember, when working with electrical systems, safety should always be your top priority. If you are unsure about any aspect of the installation, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that your installation meets all applicable code requirements. It is also important to maintain the electrical system over time. Regularly inspect the conduits and supports to ensure that they are in good condition. Replace any damaged or deteriorated components promptly to prevent potential hazards. In addition to the mechanical aspects of conduit installation, it is also important to consider the electrical characteristics of the system. Ensure that the conductors are properly sized for the intended load and that all connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to electrical fires. When working with electrical systems, always de-energize the circuit before performing any work. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical hazards. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the work. They have the training and experience necessary to complete the job safely and correctly. Furthermore, it is beneficial to continually update your knowledge of the National Electrical Code. Electrical codes are updated regularly to reflect changes in technology and to address new safety concerns. By staying informed about the latest code requirements, you can ensure that your installations are always up to date and compliant. There are many resources available to help you learn about the NEC, including books, online courses, and seminars. Consider joining a professional organization such as the International Association of Electrical Inspectors to network with other electrical professionals and stay informed about the latest industry trends. Electrical safety is a shared responsibility. By following the NEC, using approved materials and methods, and maintaining the electrical system over time, you can help to prevent electrical hazards and ensure the safety of people and property. Always prioritize safety when working with electrical systems and never take shortcuts that could compromise the integrity of the installation. Securely attaching conduits prevents stress on connections, equipment, and the conduit itself, which could loosen or break, creating dangerous conditions. Moreover, consider the impact of thermal expansion and contraction on the conduit system. Temperature changes can cause conduits to expand and contract, which can put stress on the supports. Choose support methods that allow for thermal movement to prevent damage to the system. It's also important to consider the weight of the conductors inside the conduit. Over time, the weight of the conductors can cause the conduit to sag if it is not properly supported. Ensure that the conduit is supported at appropriate intervals to prevent sagging and maintain the integrity of the system. Remember that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to ensure a safe and reliable installation. Consider the specific conditions of the installation and use your best judgment to determine the appropriate level of support and protection. When in doubt, it is always best to err on the side of caution and provide additional support or protection. This will help to ensure the long-term reliability and safety of the electrical system. Another important aspect of conduit installation is proper grounding and bonding. Ensure that the conduit system is properly grounded and bonded to prevent electrical shock hazards. Follow the NEC requirements for grounding and bonding to ensure a safe and effective installation. Regular inspections of the conduit system should include checking for signs of corrosion, damage, or loose connections. Address any issues promptly to prevent potential hazards. Proper maintenance is essential for ensuring the long-term reliability and safety of the electrical system. By following these guidelines and adhering to the NEC, you can ensure that your conduit installations are safe, reliable, and code compliant. Remember that electrical safety is a continuous process that requires attention to detail and a commitment to best practices. Furthermore, think about labeling. Clearly label all conduits to identify their purpose and the circuits they serve. This will help to prevent confusion and make it easier to troubleshoot problems in the future. Proper labeling is an essential part of a well-organized and safe electrical system. When installing conduits in concealed locations, such as walls or ceilings, it is important to protect them from physical damage. Use conduit sleeves or other protective measures to prevent damage from nails, screws, or other objects. Protecting conduits in concealed locations is essential for maintaining the integrity of the electrical system. Consider the aesthetic appearance of the conduit installation. While functionality is paramount, it is also important to consider the visual impact of the installation. Use neat and professional installation techniques to create an aesthetically pleasing result. A well-installed conduit system can enhance the overall appearance of the building. When working with different types of conduit, such as rigid metal conduit, electrical metallic tubing, or flexible metal conduit, it is important to use the appropriate fittings and connectors. Using the wrong fittings can compromise the integrity of the system and create potential hazards. Always use fittings that are specifically designed for the type of conduit being installed. Finally, remember that electrical work can be dangerous. If you are not comfortable performing the work yourself, it is best to hire a qualified electrician. They have the training and experience necessary to complete the job safely and correctly. Electrical safety should always be your top priority. The National Electrical Code, or NEC, serves as the cornerstone for safe electrical installations. Familiarity with its contents is paramount for anyone involved in electrical work. This comprehensive document outlines the standards and guidelines that minimize the risk of electrical hazards, safeguarding both people and property. Regular updates to the NEC reflect advancements in technology and address emerging safety concerns, making continuous learning essential. Ignoring code requirements can lead to serious consequences, including fires, injuries, and even fatalities. Compliance with the NEC is not merely a suggestion but a legal requirement in many jurisdictions. Electrical inspectors play a crucial role in enforcing the code and ensuring that installations meet the required standards. Their expertise helps identify potential hazards and prevent unsafe conditions. A thorough understanding of electrical theory is essential for applying the NEC effectively. Knowledge of basic concepts such as voltage, current, resistance, and power is necessary for making informed decisions about electrical installations. Practical experience complements theoretical knowledge, allowing electricians to translate code requirements into real-world applications. Hands-on training and apprenticeship programs provide valuable opportunities for developing practical skills. Continuing education courses and seminars help electricians stay up to date with the latest code changes and industry best practices. Investing in ongoing training demonstrates a commitment to safety and professionalism. Proper planning is essential for any electrical installation. Before starting work, carefully assess the site conditions, determine the load requirements, and select the appropriate materials and methods. A well-thought-out plan can prevent costly mistakes and ensure a successful outcome. Working with electricity requires a high level of attention to detail. Even small errors can have significant consequences. Double-check all connections and measurements to ensure accuracy. Always follow the manufacturer's instructions when installing electrical equipment. Using the wrong tools or techniques can damage equipment and create safety hazards. Invest in high-quality tools that are designed for electrical work. Proper tool maintenance is essential for ensuring their safe and effective operation. Never use damaged or worn-out tools. Personal protective equipment, or PPE, is essential for protecting yourself from electrical hazards. Always wear safety glasses, insulated gloves, and appropriate clothing when working with electricity. Remove any jewelry or metal objects that could conduct electricity. Follow lockout/tagout procedures to energize circuits before performing any work. This prevents accidental energization and reduces the risk of electrical shock. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Never assume that a circuit is de-energized. Grounding and bonding are essential for preventing electrical shock hazards. Ensure that all metal parts of the electrical system are properly grounded and bonded to provide a safe path for fault currents. Use appropriate grounding and bonding conductors and connectors. Follow the NEC requirements for grounding and bonding to ensure a safe and effective installation. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Select overcurrent protection devices that are properly sized for the circuit. Never replace a circuit breaker or fuse with one of a higher amperage rating. This can overload the circuit and create a fire hazard. Arc fault circuit interrupters, or of size, are designed to protect against arc faults, which are a common cause of electrical fires. Install a size and branch circuits that serve bedrooms, living rooms, and other areas where arc faults are likely to occur. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can cause electrical shock. Install GFCIs in bathrooms, kitchens, and other areas where there is a risk of contact with water. Wiring methods play a crucial role in the safety and reliability of electrical installations. Select wiring methods that are appropriate for the environment and the type of load being served. Follow the NEC requirements for wiring methods to ensure a safe and code-compliant installation. Conductor ampacity is the maximum amount of current that a conductor can safely carry. Select conductors that have an ampacity that is sufficient for the load being served. Direct conductors for ambient temperature and the number of conductors in a raceway. Conductor insulation protects conductors from short circuits and ground faults. Select conductors with insulation that is appropriate for the voltage and temperature of the application. Protect conductors from physical damage by using raceways or other protective measures. Wiring connections must be tight and secure to prevent overheating and arcing. Use appropriate connectors and terminals for the type of conductor being used. Follow the manufacturer's instructions for making connections. Inspect connections regularly to ensure that they remain tight and secure. Electrical boxes provide a safe enclosure for wiring connections and devices. Select electrical boxes that are appropriate for the application and the number of conductors being installed. Install electrical boxes according to the NEC requirements. Cover all unused openings in electrical boxes. Electrical panels distribute power to branch circuits. Select electrical panels that are properly sized for the load being served. Install electrical panels according to the NEC requirements. Label all circuits in the electrical panel. Lighting is an essential part of any electrical installation. Select lighting fixtures that are energy efficient and provide adequate illumination. Install lighting fixtures according to the NEC requirements. Use appropriate wiring methods and connections for lighting circuits. Control switches control the flow of electricity to lighting fixtures and other devices. Select control switches that are appropriate for the load being served. Install control switches according to the NEC requirements. Use appropriate wiring methods and connections for control switch circuits. Receptacles provide a convenient way to connect electrical devices to the power supply. Select receptacles that are appropriate for the voltage and amperage of the application. Install receptacles according to the NEC requirements. Use appropriate wiring methods and connections for receptacle circuits. Appliances consume electrical power to perform specific tasks. Select appliances that are energy efficient and safe to operate. Install appliances according to the manufacturer's instructions and the NEC requirements. Use appropriate wiring methods and connections for appliance circuits. Motors convert electrical energy into mechanical energy. Select motors that are properly sized for the application. Install motors according to the manufacturer's instructions and the NEC requirements. Use appropriate wiring methods and connections for motor circuits. Transformers change voltage levels. Select transformers that are properly sized for the application. Install transformers according to the manufacturer's instructions and the NEC requirements. Use appropriate wiring methods and connections for transformer circuits. Generators provide a backup source of power during power outages. Select generators that are properly sized for the load being served. Install generators according to the manufacturer's instructions and the NEC requirements. Use appropriate transfer switches to connect the generator to the electrical system. Renewable energy systems such as solar and wind power generate electricity from renewable sources. Install renewable energy systems according to the manufacturer's instructions and the NEC requirements. Use appropriate wiring methods and connections for renewable energy systems. Energy management systems monitor and control energy consumption. Install energy management systems according to the manufacturer's instructions and the NEC requirements. Use appropriate wiring methods and connections for energy management systems. Smart home technology integrates electrical devices and systems into a network that can be controlled remotely. Install smart home technology according to the manufacturer's instructions and the NEC requirements. Use appropriate wiring methods and connections for smart home technology. Electrical safety audits identify potential hazards and ensure that electrical systems are code compliant. Conduct electrical safety audits regularly. Address any issues identified during the audit promptly. Electrical maintenance prevents electrical hazards and ensures the long-term reliability of electrical systems. Perform electrical maintenance regularly. Follow the manufacturer's instructions for maintaining electrical equipment. Electrical troubleshooting identifies and resolves electrical problems. Use appropriate tools and techniques for electrical troubleshooting. Follow safety precautions when troubleshooting electrical problems. Electrical repairs restore electrical systems to proper working order. Use qualified electricians for electrical repairs. Follow safety precautions when performing electrical repairs. Electrical upgrades improve the performance and safety of electrical systems. Use qualified electricians for electrical upgrades. Follow safety precautions when performing electrical upgrades. Electrical inspections verify that electrical installations are code compliant. Use qualified electrical inspectors for electrical inspections. Address any issues identified during the inspection promptly. Electrical permits are required for many types of electrical work. Obtain electrical permits before starting work. Follow the requirements of the electrical permit. Electrical codes and standards are constantly evolving. Stay up to date with the latest codes and standards. Participate in continuing education courses and seminars. Electrical safety is a shared responsibility. Work together to create a safe electrical environment. Report any electrical hazards immediately. Follow safety precautions at all times. And remember, when it comes to electrical safety, there is no substitute for knowledge, experience, and caution.